Morning, gents. Welcome to Physics Course Year 10. And our first lesson is going to be on quantities, symbols, and units. And what we're going to look at is the common symbols and units that you're going to use in this year in physics, and hopefully subsequently in Year 11 and 12 if you decide to take it up with us. So let's go through this. First thing I'd like you to do though is to pause the video and copy the table with the three headings: quantity, name of unit, and SI unit. When you've done that, you can then restart the video. Welcome back, gents. So all of these symbols and SI units are agreed internationally with the scientific community. So that means when anyone's reading a scientific paper or they're going to publish one, everyone can instantly recognize the symbols. So this is why it's been done. And this is called the metric system. You may have heard of the imperial system, which is the Americans use, and they still work in things like pounds and miles an hour and gallons. So we no longer use that. That's an old style. And the scientific community all use this way of communication. So, first of all, I'd like you to copy. We're just going to go through one at a time now, but I'd like to copy as we go through. So, first one would be time. That's the quantity. The name of the unit is the second, and the SI unit is a lowercase s. So the symbol that we use for that is lowercase s. Now I know for time that we can use the minute, we use the hour, week, years. But the basic unit that they will use, the System International unit, the SI unit, is the second. And as I said, it is going to be lowercase. And you'll notice that most of the letters will be lowercase unless they're named after a scientist, or they conflict. So, for instance, if we look at the meter is lowercase m, but we notice that an uppercase M is used for mega, which means million. So there's a conflict there. Let's go on to that. So distance would be the meter and lowercase m, which we spoke about. Now again, we know that distance is quite often used in kilometers. When we look at things like space, we even go to a larger unit, which we'll look at light years. So continuing through, energy. Now this is named after famous scientist, Joules. So now we give a capital letter as opposed to a lowercase letter, which we've been using before. Mass. Now mass is one of those terms that is used in the wrong context pretty much in everyday life. Most people ask you for your weight, and you would actually give your mass. So if someone asks you your weight, you go, look, I weigh 60 kilograms. Well, in physics, that's not true. In physics, your weight is a force. And in order to find your weight, you must take the mass, which would be in kilograms, and multiply it by g, which is the acceleration due to Earth. So that's the true sense of weight. In everyday life, though, you're going to continue using mass as your weight because that's what people are familiar with. But in a science lab, that's not true. It's going to be a force of weight, which is going to be your mass, which is in kilograms, multiplied by the acceleration due to gravity, which is 9.8 meters per second. But we'll come to that a little bit later on. There you go. The next one is weight. So weight is measured in newtons, and Newton's a famous scientist, so capital N. Force. Now, there's a number of different forces, and again, force is measured in newtons, and the symbol is going to be capital N. Power is measured in watts. So power, if you think of how powerful you are, means how quickly you can convert energy. So really, the true units for this, it was named after a scientist, but the true units for this is how many joules can you use a second. And if you're really powerful, you can convert a lot of joules of energy per second. And that's what we mean by power. But we give it the symbol W, which is going to be a capital W. Temperature, you'd have come across this many times already in the lower school, and we're going to get 2 ones now. We're going to introduce you to another one, degrees Celsius, which is a common one we would use, or Kelvin. Okay, and you'll look at that pretty much in year 11 a little bit more, but they're the 2 symbols for those. Either one you can use, but pretty much this year we will stick to degrees Celsius. Displacement, some of you may have come across this term before, and we will have a whole lesson on distance and displacement, and that is measured in meters, and again the symbol is exactly the same as for distance, which is m, lowercase. Okay, coming to the last part of this now, speed. Well, if you think of speed is what distance do you travel in a certain time, so therefore the actual units are going to be meters per second. And how do we show that? Well, there's a number of ways that we can show this. One, you're allowed to represent this as, let me just rub this out and I'll redo it. So this is if we look at this here, gents, just on the right hand side, that's how I'd find the speed of an object. I'd find out how far they've gone in meters, and I would time them in seconds. So I can write this in a number of ways. Either one is acceptable. You can put meters per second, but really you quite often see it written like this, but that's what it means. That little line at the side just means meters per second. Or you're allowed to say meters per second to the -1, which means that S has come up from underneath and it's now on there. So either one of those ways is acceptable. Again, velocity, I'm not going to go into that now, but again, we will have a whole lesson on speed and velocity. And if you notice, it's still got the same units of speed. So we've got meters per second. And again, I'm allowed to represent it in either way as what I just did before. Now, velocity, I'll just quickly talk about that there. I've just put is found by dividing displacement divided by time. So again, I will come back to that when we have a whole lesson on it. And then I'm just going to rub those out just for the moment. Okay, the last one we're going to look at is we're going to look at acceleration. Now, acceleration is really, it's a change in speed over time or change in velocity over time. So that means that you're no longer going at a constant speed or velocity. You're either increasing that per second or decreasing it. So therefore, acceleration is going to be meters per second. And you're allowed to write it meters per second or ms to the -2, as opposed to if we looked at there, that was to the -1 because that just came at 1. But this, if you look at it, I had meters per second, which would be to the -1 per second. That's why we get to the -2. All right, gents, well done. Now go back to the sector, print off the course outline, put that into your physics file, then print off the first few pages of certain activities and extra information, and then put that into your file and then complete everything that you need to. Well done, gents.